Hello and welcome to Skolaris Weekly. I'm your host, Martin Klemsa. Today we're going to have a look at the algorithms that optimize your timetable in Skolaris. As you probably know, when you open the optimization settings, there is this computation section at the bottom. So let's expand it and see what it offers us. So the algorithm drop down, and there's a list of algorithms that you can choose from. The smart optimization is the default, which is going to be run whenever you press play. Let's just choose a subset here of the demo data so that the algorithms run really fast. So let's just generate a timetable for two class groups here, for 5A and 5B. Okay, let's try the smart optimization first. Finished. Let's consider soft constraints. So after 1 minute and 8 seconds, our smart optimization is finished, and this is the best timetable that Skolaris will give you. So just for reference, the fitness is 93.5% and the absolute fitness is 40. In fact, this is a perfect timetable from the point of view of these two class groups, because the only broken constraints are minimum teaching periods per day. But if we have a look at those teacher timetables where these broken constraints occur, we will see that these teachers simply do not teach enough periods in order to have 2 periods per day. If these two lessons, for example, were placed both on Monday, it would mean that the physical education for girls in 5A and 5B would be on the same day, which is much worse than this teacher having to teach just one lesson on Monday and one on Wednesday. So it's also an example of constraints that contradict each other. The distribution of this course and teacher minimum periods per day go against each other and will never be satisfied all at once. So this is the smart optimization that everybody knows, but what do the other algorithms do, and what results will they give us? Let's discard and choose the second one. This is the fast optimization. It's actually what happens when you hit the fast forward arrows here just beside the play button. So now when I press play, it will actually start the algorithm which is selected in this drop down. So I can either press the fast optimization here, which will always start the fast one, or press play, which will start the selection, which is the fast optimization. So let's press play. The fast optimization has finished after 26 seconds, as opposed to 1 minute and 8 seconds for the smart one. But we can see that the result is worse. It's 89% fitness. And if we open the breakdown, we can see the absolute fitness is 70. So there are 3 more broken constraints than with the smart optimization, which is the default option. So this one is faster, but may not find as good a solution as the smart optimization. Let's choose time random non-ascendant search. What this does is randomly shuffle the timetable, and if such shuffling produces a timetable of a better or same quality, it will use the shuffling move Otherwise, it will discard that shuffling move. Let's see what happens with this algorithm. A feasible timetable could not be found. If you look closely, you will see why. The rooms have not been assigned. So this time random non-ascendant search doesn't actually change the room assignment. It is not able to change the room assignment. So let's follow this with room random non-ascendant search, which is the opposite. It only changes rooms. It shuffles rooms, but never the time. Let's press play. And this is very fast. And now we can see that we haven't reached a healthy timetable because the required spread for physical education for boys has not been met. It is not in the nature of the random non-ascendant search algorithms to find a very good solution, but because they are really, really fast, you could see that it only took a few seconds to run both of them. They provide a good starting point for the true workhorses of Skolaris optimization, which are the time taboo search and room taboo search. So let's select time taboo search and start from scratch. And in 15 seconds we have the result. And this is the same result that we got with smart optimization, but it took more time. Sorry, it took less time. For really simple data sets, such as the one that we're using at the moment, this is normal behavior. Time taboo search provides reasonably fast optimization and good results. If this were a real school where the data is more complicated, the taboo search alone might not be able to find such a good solution. For the completeness here, let's try the room taboo search as well. But actually let's run the time algorithm first. The time random non-ascendant search. This is the really fast one without rooms. Now room taboo search only changes rooms, and it's also really fast and provides similar results to the room random non-ascendant search. Now the last one in the list is incremental generation. Let me show you first what it does, and then let me explain a bit more. It's going to be really fast, so don't blink. There we go. So what is this? This looks kind of useless, doesn't it? Incremental generation takes all unscheduled lessons and puts them in the timetable so that they don't clash, if possible. It's a similar approach to what people would do when trying to assemble a timetable manually. Just take lessons one by one and place them into the timetable and check various constraints while doing so. The difference between the human approach and incremental generation in Skolaris is that incremental generation only looks at the double booking constraint. It doesn't consider start of the day, it doesn't consider gaps, and so on. It is there to provide a starting point for other algorithms which may not work well with unscheduled lessons. This is also a similar algorithm to what other timetabling software or older timetabling software might be using. Only they have obviously advanced it a little bit more to give more useful results. But the principle is the same. Insert lessons into the timetable one by one, whereas all the other algorithms here actually work with lessons already in the timetable and shuffle them in a way that tries to produce a better timetable than there already is. So if we start from this point and execute timetable search, for example, you'll get a good result really fast. Almost immediately, we've got the best timetable that we were able to find with the smart optimization. So this is finished quickly and we get the best result again. So that is all of the algorithms really quickly. If you want to know more, or if you want to play with them more, you can also expand algorithm parameters, which will bring you to a complex world of timetabling optimization parameters, and maybe we're going to talk about them some other time. That's all for today. Thank you for watching and have a nice day. Bye.